Today we like really have a short, kind of funny, unusual paper. It's only 5.5 pages, and I didn't feel like really preparing the slides because like conceptually it's not a difficult paper to like understand at all, right? And it explores kind of an interesting problem, and when I say interesting, like to my mind, it's kind of a very unusual problem, right? So the paper is called Deep Note, can acoustic interference damage the availability of hard disk storage in underwater data centers, right? And so, yeah, what this paper is trying to do is trying to see if we can, play some sound underwater with some, underwater speakers, and if that can, stop your mechanical hard drives from working. Right, and the idea is, of course, because mechanical hard drives, HDDs, they're mechanical, right? So they have like a lot of moving parts, and when you need to read or write the data from that disk, which like spins and whatnot, and there are magnetic heads that need to move. There are very like tight tolerances for the placement of the magnetic head, above the disk plates and whatnot. So if somehow those tolerances can be, messed up with, then the disk becomes inoperative, right? So, and the vibrations from the sound wave, vibrations from the sound may, mess up those tolerances just enough and, essentially make the disk non-functional while that, sound, those vibrations are present. And, the paper talks about like the prior studies that kind of tried to do this on a laptop computer in air, right? But they try to think kind of outside of the box a little bit and say, well, the sound travels like much nicer and easier in water, right? And now we start to have underwater data centers. Right, so we have things like this being tried up, right? So they put like a big box with servers and whatnot underwater. The tin with servers, it doesn't have air, so they replace the air with like pure nitrogen atmosphere, and they hope that by placing those containers under the water, they can save on cooling costs because of like the natural coldness of the ocean and whatnot. So yeah, so this is what this paper is trying. Of course, it doesn't have the Microsoft branded underwater data center prototype, right? So they went with like a really tiny scale experiment, right? So they have a tank, with water, and in this tank they put essentially a hard drive, and they put it in one of the two different containers. They either put it in a plastic box or the metal box, and then they also tried with essentially putting the hard drive in a kind of a small hard drive like storage tower, and then put it in a plastic box, and then put it in a metal enclosure to kind of try to simulate the server rack, right? So this is a very crude and very low scale approximation and simulation of of what happens inside that inside that. So and they play some speakers, right? And they play some some sound, and they actually try different wavelengths to see there is a particular wavelengths that may cause more problems, right? And of course they want to study like what kind of problems can they cause and how far can they place the speaker away from the box, either the plastic box or metal box, and still cause the problem. So they tried this three scenarios, right? So they tried the plastic box, and they just put the hard drive, the mechanical hard drive, at the bottom of the box. and just have the speaker to the side. They tried the same plastic box, but now with this kind of storage enclosure. So the hard drive is not directly touching the walls of the box. And then they tried, the metal box with the enclosure as well. So you can see that, like in this pictures, at least, it seems like those boxes are not fully submerged, but they claim that the hard drives in all the cases are located like under the, like below the water level, below the surface. Yeah, I mean, that's what the setup is. And let's jump to essentially what they find. And in figure 2, they show us different frequencies that resulted in throughput degradation, right? So figure A is sequential writes, figure B is sequential reads, and essentially they show that like the lower end of frequencies tend to make the hard drives not work well. And by lower end, specifically, I think they say from 300 megahertz to about 1700, I mean, 300 hertz to 1700 hertz. So, it's definitely like audible, range. Yeah, so like everything is like under 2 kilohertz. And that works both for writes and reads. So, playing that sound can cause the throughput to degrade both on writes and reads. They also say that it's more apparent on writes, and that's probably because there are tighter tolerances for the magnetic head placement with like regards to where to the disk plate for writes. So those vibrations can disturb things more in the hard drive. And there are some other data that they have, like the distance at which the attack can happen, right? So those are very like short distances, really, right? So like 1 centimeter, 5, 10, so like up to 10 centimeters in the plastic container, they can essentially stop the hard drive from operating. So this is the RocksDB database trying to work on that hard drive. I think, yeah. So another thing that they tested is, hey, how long does it take to fail? And they say they can play the sound for about 80 seconds or so. The file system starts to fail, which eventually causes the operating system to fail, and everything else fails after that. Right, so if you can play that sound, at 5 centimeters from the container for 80 seconds, you can, stop the server. That's kind of neat, but yeah, obviously, this is a very small like scale test, right? So a lot of kind of research needs to be done to see if this is actually a problem in those bigger things, right? Because like 25 centimeters, was the maximum distance that they tested, right? And this is not a plastic box, so maybe it will resonate more, right? Maybe it has like good, dampening somewhere, right? Or like the way that the servers are, like the racks are installed there, there is like good dampening so that the vibrations don't pass through. Which I would expect something like that to happen because the water may move and I don't know, waves and yeah. So yeah. Anyway, I think that's all I want to say about the actual paper. For the sake of the presentation.